Good morning everyone, it's me Reynalyn, mariz, esteron, and welcome to my video. So for today's video, we are going to tackle the CCNA 1 summary. We have the chapter 1 to chapter 11. So for the first chapter, we are going to tackle the explore the network. Networks and the internet have changed the way we communicate, learn, work, and even play. So I have the list of the communication that we are using now. Texting using our mobile phones. Social media like Facebook, Instagram, Messenger, and etc. And the collaboration tools, blogs, wikis, podcasting, and peer-to-peer. Networks come in all sizes. They can range from simple networks consisting of 2 computers to networks connecting millions of devices. For the first size of networks, we have the PAN, which is Personal Area Network. For example, we have here a laptop that is connected to a headset or earphones, connected to a mobile phone, and connected to another laptop, connected to a mouse, and connected to a printer. So this is the example of a personal area network. We also have here the LAN, which is local area network, or WLAN, wireless local area network, like the Wi-Fi. For example, we have here a Wi-Fi. Then it is connected to a computer A, computer B, computer C, computer D, and a computer E. It also connected to a wireless printer. So this is the example of a LAN. So we also have the Metropolitan Area Network, or the MAN. Metropolitan Area Network is a computer network that interconnects users with computer resources in geographic region of the size of a metropolitan area. So for example, we have here a city that is connected to another municipalities. This is the city that is connected to a municipalities. We also have the WAN, which is Wide Area Network. A wide area network is a telecommunication network that extends over a large geographical area for a primary purpose of computer networking. So for example, we have here the headquarters, or the main headquarters. We also have the Office A, Office B, Office C, and Office D. The headquarters is connected with the Office A, and the Office A connected with Office B, and the Office B is connected to Office C, and Office C is connected to Office D, and also the headquarters are connected to Office D. So the headquarters is also connected with the B, the Office C, and the Office C is connected to Office A, and the Office B is connected to Office D, and Office A is connected to Office D. So it is the example of wide area network. So we also have the SAN, or the storage area network, which is a network is a computer network which provides access to consolidated block level data storage. So for example, we have here the main server, or the other server, or the server A and the server B. They are also connected to a PCA and PCB. And the server B is connected to PCC and PCD. So this is an example of a storage area network. Clients and servers are all end devices called hosts. So, the example of the end devices are the computers that is connected to a server. Peer-to-peer, many computers function as the servers and clients on a network. We have the network components, which are the devices or the physical elements, media, and the services. We have the end devices that I was talking about earlier, the desktop computer, laptop, printer, IP phone, wireless tablet, and telepresence endpoint. So we also have the intermediary devices, which are the wireless router, LAN switch, router, multi-layer switch, and firewall appliance. And we have also the network media, which is copper, fiber optic, and the wireless. Wireless is the example of a wireless Wi-Fi that we are using in public, in universities, schools, house, and other places. And we also have the topology diagrams. Physical topology diagrams identify the physical location of intermediary devices and cable installation. And logical topology diagrams identify devices, ports, and addressing scheme. We also have the tranets, the intranet, and the extranet. The intranet is a private network that can only be accessed by authorized users. So for example, we are using a mobile phones or a laptop or a personal computer. We can access to a mail, social media accounts that has privacy. The extranet is control the private network, allowing customers, partners, vendors, suppliers, and business to gain information typically about a specific company or educational institution and do so without granting access to the organization's entire network. For example, in a mobile phone, you are going to connect to his internet or to his tethering. You, the owner of the mobile phone, need to accept the permission of the Wi-Fi that or the mobile phone that want to connect to his tethering. And the business internet connections, dedicated list line, Ethernet 1, DSL, satellite. Network and the network architecture, which are the fault tolerance, scalability, quality of services or cost, security, new trends, bring your own device or BIOD, online collaboration, video communication, and cloud computing. So for the next chapter, we are going to tackle to configure a network operating system. Cisco IOS is a term of encompasses a number of different operating systems which runs on the various networking devices. The technician can enter commands to configure or program the device perform various networking functions, or Cisco IOS router and switches perform functions that network professionals depend upon to make their networks operate as expected. We have the operating systems, which are the shell, kernel, and hardware. The interfaces, command line interface or CLI, graphical interface or GUI, the access methods, which are the console, that physical management port, secure cell or SSH, a remote secure CLI connection through a virtual interface, a telnet, a remote and secure CLI connection through a virtual interface. So we are going to proceed to the chapter 3, which is the network protocols and communication. Data networks are systems of end devices, intermediary devices, and the media connecting them for communication to occur. These devices must know how to communicate. So we have the establishment rules, which are an identified sender and receiver, common language and grammar, speed and timing of delivery, confirmation or acknowledgement requirements, message timing, access method, or a method that determines when someone can send a message, when to begin and sending message. A flow control the time between two frames, and response timeout. We also have the message delivery options, which are the unicast, multicast, and the broadcast. So we are going to proceed to chapter 4, which is network access. The OSI physical layer provides the means of transport and the bits that make up data link layer frame across network media. The physical components are the electronic hardware devices, media, and other connections that transmit and carry signals to represent the bits. So, we have here the types of communications, or home router, Ethernet switch, the internet connection, and embedded wireless antenna. And we also have the physical layer, which are the copper cable, the signals, and the pagerms of electrical pulses, the fiber optic cable, and the signals that patterns of light. Wireless, the signals are patterns of a microwave transmissions. Physical layer standards. We also have the standards of a physical layer, which are the International Organization Standardization, or the ISO, the Telecommunication Industry Association, Electronic Industries Association, or TIA or EA, and the International Communication Union, or ITU. We also have the American National Standard Institute, or ANSI, and Institute of Electrical and Electronics Engineers, IEEE. Then we also have the physical layer standards, which have the physical components, the electronic hardware devices, media, and connectors that transmit and carry the signals. The encoding is a method of converting and stream the data bits into predend code. And the signaling. The physical layer must generate a one electrical, optical, or wireless signals that represent of 1 and 0 on a media. And the bandwidth. The rate of transfer of bits on a media. The types of physical media are the fast Ethernet switch port, SHDSL interface, management ports, gigabit Internet interfaces, USB Type A connector, and interference copper cable, electromagnetic interference EMI, or radio frequency interference, which is RFI. The crosstalk. Disturbance caused by electric or magnetic fields of signal on the wire and an adjacent wire. We also have the copper media, the unshielded twisted pair, or UTP, shielded twisted pair, or STP, coaxial UTP cabling standards, cable types, cable lengths, connectors, and cable terminations, or methods of testing cable. We also have the types of cable, or UTP cable, Ethernet straight through, or the typical straight through, and the crossover. The other side is straight through and the other one is crossover, and the rollover. We also have the chapter 5, which is Ethernet. Ethernet MAC sublayer, data encapsulation. Frame delimiting. The framing process provides important delimiters that are used to identify a group of bits that make up the frame. The addressing. The encapsulation process contains the layer 3 PDU and provides for data link layer addressing. Error detection. Each frame contains a trailer used to detect any errors in the transmissions. The media access control. Control of frame replacement on the OD and the media. Media recovery. Broadcast MAC addressing. Multicast MAC addressing. MAC addresses start with 01-00-5E. Frame forwarding methods on Cisco switches. Store and forward switching. It receives then a frame and computes the CRC. If the CRC is valid, the switch looks up and destination address 16. And the next chapter will be the network layer. The network layer or OSI layer provides servers to allow end devices and exchange data across the network. To accomplish this end-to-end transport, the network layer's users for basic process, IP addressing for end devices, encapsulation, routing, and the encapsulation. Process of network layer. Addressing end devices. End devices must be configured with a unique IP address for hidden on the network. The encapsulation. The network layer encapsulates the protocol data unit PDU from the transport layer into the packet. The routing. The network layer provides service to direct packets to the destination host on another network to travel to another networks, and packet must be processed by the router. And the encapsulation. When the packet arrives at the network of the destination host, the IP header will be removed. Network layer protocols. The Internet Protocol or version 4 IPv4, Internet Protocol version 6 IPv6. Characteristics of the IP protocol. The connection list. No connection with the destination is established before sending data packets. The sender doesn't know receiver is present, packet arrive, and receiver can read the packet. The receiver doesn't know when the packet is coming. Best either delivery isn't guaranteed. The media independent is the operation of independent of the medium carrying data. In the chapter 7, we are going to have the IP addressing. IP addresses are hierarchical with network, subnetwork, and the host portion. An IP address can represent to a complete network a specific host or a broadcast address of a network. IPv4 address structure. IPv4 address is a unique IPv4 address for the host. The subnet mask used to identify the network host portion of the IPv4 address. And the default gateway identifies the local gateway to reach remote networks. The PV4 communication. Unicast. The process of sending the packet from the host to an individual host. Broadcast. The process of sending packet from the host to all hosts from the network. The multicast. The process of sending packet from the one host to a selected group of hosts, possibly in different networks like 224.0.0.0 to 239.225.225.225. Addresses are reserved for multicasting. In the chapter 8, we are going to have the subnetting IP networks. The process of segmenting the network by dividing it into multiple smaller network spaces is called subnetting. Every network address has a valid range of host addresses. All devices attached to the same network will have an IPv4 host for that network, common subnet mask, or network prefix. IPv4 subnet PNG. So, in this picture, we can see that the prefix, length, subnet mask, in binary, and number of hosts. The IPv4 subnets are created by using one or more of the host bits as the network bits. So we are going to proceed to chapter 9, which is the transport layer. The transport layer provides transport-related services by dividing data received from an application into segments, adding a header to identify and manage each segment, using the header information and reassemble the segments back into application data, and lastly, passing the reassembled data to the correct application. UDP and TCP are common transport layer protocols. The UDP datagrams and TCP segments have headers added in the front of the data that include source port number and destination port number. So, in this picture, we can see the enabling application and device to communicate. For example, telephone to telephone, computers to computers, laptop to laptops, and mobile phones to mobile phones. So, in mobile phones, we are going to have texting, social media, as long as we have the internet connection. For the last chapter, the chapter 10, application layer. So, for the application layer, it is responsible to directly accessing the underlying process of manage the deliver communication to human network. This layer serves as source and destination of communication across the data networks. The application layer application services and protocols enable to interact data network in a way that is meaningful and effective. Application are computers program with which user interacts, which initiate the data transfer process and user's request. Services are background programs that provide connection between the application layer and the lower layers of the networking model. Protocols also provide a structure of agreed upon rules and process to ensure running on one particular device can send and receive data range in different network devices. So we can see the OSI model, which are the application, presentation, session, transport, network, data link, and physical. The application layer is closest layer to the end user, and the application layer provides the interface between the application used to communicate and the underlying network which messages and transmitted. Application protocols are used to exchange data between programs running on the source of destination host. Presentation layer, the three primary function, which is format, PNG, or presenting data at source into a compatible form for receipt by the destination device. The compressing data in a way that can be decompressed by the destination device. Encrypting data for transmission and decrypting upon the receipt. And lastly, the session layer. The session layer creates and maintains dialogues between source destination on applications. The session layer handles the exchanges information to initiate dialogues, keep them active, and restart sessions that are disrupted to idle for a long period of time. And that's all. Thank you for watching and hope that you can learn something about this video.